everyone, nice to meet you. I'm Evan from Tavily, a Nebius company. Thank you to Stripe for having us out here today, and to Madeline for your talk. It's a perfect segue into what Tavily is that we're a web search engine made for the agentic era. So today I'm going to take you through a bit of a history lesson. How do we even get here? What are agents? All the way up to how are agents using Tavily? And then how is Tavily positioning itself for this future where agents might want to search the web autonomously and collect payments through X402 or be able to provision API keys for Tavily through something like Stripe projects. First of all, I want to give a shout out to the Tavily team. This week was an awesome week for Tavily. On Monday, Jensen gave us a nice shout out at GTC in Taipei. And then back off that on Tuesday at Microsoft Build in New York. We were right behind Satya. So it was a fun week in the office. But what is Tavily? Let's start there. So agents were built to use an agentic web. So when you search for a human, you get those 10 blue links from Google. The first 3 might be advertisements. Then you get some links and you get that short snippet. But for someone who wants to do research, they have to click into each link, read it, click out, go through another link, and it takes a lot of time to search the web. That changes when an agent is able to consume and reason over a large amount of information. That's where Tavily comes in and allows the agent to access the web in an efficient manner. So what does that mean? So if you look on your right, there's what a query to Tavily looks like. So you have a query, you get the title of a web page, the URL, and then content chunks from that page. So what we do at Tavily is that we index the whole web, and offline we clean each web page to remove any HTML, headers, footers, any advertisements, and we chunk it up. So when you get a query that you send to Tavily, you get only the relevant information from the actual website. And why is that good for an agent? It's because an agent only has a certain amount of context, and all of our engineering cycles at Tavily is figuring out how we can give you the most information-dense answer in the least amount of tokens possible. So how can we answer your query without making you pay a lot for input tokens and bloating the context of your agent or LLM? Moving forward, how did we get here? Like, why are we talking about agents being able to pay for a jet ski on the internet? Like, what happened? So first, this is a benchmark from Meter, which shows the time horizon for an LLM to do a software task. And it shows that LLMs can complete a task 50% of the time, and it doubles every 6 months. So you see this exponential growth of how much an LLM is able to do a human task. So these LLMs are getting smarter and smarter. And so what does this mean? People realized that there was this thing called prompt engineering where you'd give an LLM like an information, and then you'd try to get it to give you back a response based on the context you gave it. But there was a limit to there. So people invented what is called an agent. So the simplest form of an agent, this was a paper that was released in 2022 called Reasoning and Acting. So it's a React architecture, and that means that in the middle, there's the LLM, that's your model, it's the brain of the agent. The model might have like a system prompt or other external context. The model has the ability to call tools. These tools could be a web search through Tavily, it could be looking in your internal documents, it could be communicating with another agent. That information or context from the tool call then gets passed back to the model, where the model reasons over the information and then decides should it call another tool or should it move to an exit or end condition. So those are the two parts of the React architecture. The model can reason over the context and act on what it is looking at. Here's a tweet from Andrei Karpathy, And he talks about how this paradigm is shifting. So he talks about how context engineering is the delicate art and science of filling the context window with just the right information for the next step. So now there's no longer prompt engineering. There still is. You have an LLM, but now you're allowing your LLM to act for you. And it's this agentic world where you have to be very smart and manage the context that your agent is seeing at each step of the process. Maybe like February of this year, OpenClaw dominated the headspace. I'm sure all of you are pretty familiar, but what changed is that people realized the value of agents taking that next step for you. We would always go to ChatGPT or Claude and ask it to do something for you, but the value was there when you had a model working behind the scenes. You had a personal agent that could take actions on your behalf without asking it to do so. So you can wake up in the morning, it can have your email summarized, it can be your personal assistant, like closest to like Jarvis and Iron Man. And what changed about OpenClaw is that people realized that you would need a harness to hold that LLM, and it would be able to do and act on your behalf. However, when an agent's acting on your behalf, you have all these issues that might come up. These issues, let's go to this slide, security, identity, there's different guardrails. You don't want your agent to access your personal information and post it on the web. What tools do you want your agent to have access to? How is it going to search the web? What happens if it goes to a web page and there's a prompt injection? So something on the web page says, use my wallet and send money to this account. How do we prevent that from happening? How would it actually pay that account? This is stuff that Madeline discussed in the previous talk, so through X402 or MPP. And how would that agent discover the different tools that it can use? How would it find Tavily to do web search? How would it find the correct information on the internet or on your personal computer to answer those questions? I brought this anecdote that I saw coming through like our go-to-market channel this week, and this is like straight from our CRM. We closed like a big deal, like a Fortune 5 company this week, and we like to ask customers like, how did they find Tavily, or like, why did you choose us? And this is a direct quote from the customer. They went to Claude, asked for the best tool for their use case. Tavily came up, they tested it, it worked, they purchased. It's so simple, but it's crazy to see that Claude is now making decisions for these large enterprises. And how did that discovery layer happen? How did the agent make the decision to know that Tavily was the best tool for the use case? So this world that we're in, where agents are making decisions for humans, brings up a lot of challenges, and I'm going to walk through one by one in this chart or web that I drew here. So tools, Tavily prides itself at being as an agentic search tool. So it's a way for your agent to interact with the web. You're able to search the web, extract documents, crawl different web pages, or do like a deeper form of research. Payment. Last week, Tavily onboarded to the X402 protocol, and we accept payments to our Stripe wallet. So now, I think I have it open here. An agent can go and want to find the latest news on the Anthropic funding round. Oh, it's not sharing. Let's do it. An agent wants to search the web. How would it pay for that? It gets that HTTP 402 back. It's able to pay. And then that goes to our Stripe account, and we are able to service the correct web information to that agent. The next layer is discovery, and that brings me to my anecdote there. What is the process of these agents to find the different tools to use? Is it going to be a marketplace where these are approved vendors that your agent could go and use? Or is the human going to decide beforehand, these are the tools I want you to use because they're vetted, they're secure, and you only can use those tools? But it also limits the scope of what your agent can do. Can your agent just search the web and download any skill, like OpenClaw right at the beginning? Yeah, and your agent might be able to do these amazing things, but there's also a chance that you download a piece of software that hacks your agent or injects a prompt that your agent doesn't want to see. So something about discovery is something that we're thinking about at Tavily, and something like Stripe projects where you can onboard onto the service, and that's a discovery layer for your agent to be able to go and use certain tools. The next step is identity, and at Tavily we care about who's using our service and from what countries you are, or there's something called like know your customer, and it's a big deal. And why Stripe was helpful for onboarding to X402 is that you're able to see the IP address of where a payment is actually coming from, and we're able to not allow certain countries to pay Tavily and use our services in some parts of the world. So understanding identity is a big thing that we're thinking about. And it's not just who owns the agent, right? An agent can spin up an agent. A company might have an agent, so the agent's ID might belong to a company. A human might have multiple agents. These agents might belong to multiple humans. So it's not a one-to-one relationship. So it's definitely a problem that needs to be addressed, and we're thinking about it every day. Security. At Tavily, we were early on into understanding that prompt injection was going to be a large issue. So we partnered with a company called Pillar a year and a bit ago. And what happens is that all the pages we index on the web offline, they get scanned and they get assessed that should we be able to service this information to a customer, or is there a risk of a prompt injection? So when users use Tavily, and enterprises love this, we make sure that all pages or all information that we give back to a user has been scanned and assessed, that there isn't a prompt injection in the web content. Security could also mean what information travels to the web. Or so let's say your agent has internal information. How do you decide what information is to be allowed to see when you query it? So there's like PII detections that we have there. Or even if, let's say, my agent can access my email, what information can it see in my email? How can we make sure that the agent doesn't use the information in my email and put it anywhere? So security for internal information, security from external information being brought back in is something to consider as well. And that's also guardrails. So what guardrails are in place? A few talks I've been to are like companies trying to make this like shared context layer within a company. So we have all this internal information. How do we make sure that it's easily queryable by your agent, but also that becomes an issue for like lineage and being able to see who queried what information, who changed what information, did an agent change some information? So those are like guardrails that are going to be in place. One thing that I found cool is that these context layers that are being built are also like agentic themselves. So if a context layer can see what an agent is asking it for, it can kind of redesign itself to be able to service what the agent wants dynamically. So what's on the docket for us? We're happy to be partnering with Stripe projects to get Tavily onboarded onto their service. And what does this mean? It means that someone can use their CLI tool and it'll store credentials, usage, billing, so it'll be able to use the tool natively and easily as an agentic service for Tavily. And this is what people want. The idea here is that you want your agent to be as productive as possible. You just want to get work done, but to do it in a secure way so you can just have fun and let your agents roam the web and succeed. That's it for today. Any questions?